After dropping any incomplete data and taking a look at the results, you are tasked with normalizing the data. Above, when we looked at our clean counties data frame, you could see that the range of features was really large. Some of these columns have really big and wide-ranging values, and others have percentage values. Since unsupervised learning relies on looking at the relationships between features, I want these features to be consistently comparable. In fact, I want to scale all of these numerical features into a range between 0 and 1. And I can start to do this with a call to the sklearn pre-processing library, where I can import a min-max scalar. I can create a scalar object which is able to look at the minimum and maximum values in a feature range and divide every value by that range to get a normalized value between 0 and 1. So I'm creating a scalar, then to get my county scale data frame, I'm using fit transform, passing in my clean counties data frame as a float type, and applying that min-max scalar. This is a pretty typical normalization step. Now I want the features and the indices to be the same for this scale data frame as they are in our clean counties data frame. That is, I want the columns to be our features and the indices to be our state county indices. And let's see the result. Now I can see that all of these numerical values are in decimal ranges. I can even go one step further and check that the maximum and minimum are what I expect. By calling .describe on a data frame, I can see stats like the minimum and the maximum value. And indeed, they're 0 and 1 respectively for all of our numerical columns. So we cleaned our data, we got rid of our categorical columns, and now we've just scaled it. Now we're almost ready to put this through a PCA model and reduce the dimensionality of this data for future analysis. Let's learn more about PCA next.